studying about what Fourier cosine and sine integrals. So as we have defined the Fourier cosine and sine series on the half intervals, what were those? Those were defined on this half intervals where we have constructed our series to be either even or odd, depending upon we want the cosine series or we want the sine series. So this we have already done. We have constructed this sine and cosine series for half intervals. Now we will define the corresponding Fourier cosine and sine integrals on this real half line. So that means we are not taking any finite half interval but the infinite half interval from 0 to infinity. So for that, what are the conditions? The conditions, first condition is that the function should be defined for all values of x greater than equal to 0. Moreover, this integral should converge. That means we say f that is absolutely convergent. So for the Fourier cosine integral representation of f of x, we use the even extension as we have done in the half series cases on the whole real line now. So what we do, we convert our given function f of x into some new function. This is some new function g of x where we now take its reflection along y-axis so that it becomes an even function now. How does it become an even function? For all the values of x greater than equal to 0, it is the function itself. That means we are not changing anything. But in the left hand side of this interval, so if we have this interval from minus infinity to infinity and this is the point 0, we are saying in this interval our function is f of x only, and when we take its reflection about this axis, so what we are doing, we are changing it from f of minus x. So that means your function would be the same when you substitute minus x in place of x. So this is what we have just written mathematically. So what we have done, we have created a new function g of x such that it is now an even function. So if this is an even function, so what is the integral formula that we already know? The integral formula earlier it was f of x that is equal to 1 by pi integration from 0 to infinity a omega cos omega x d omega plus integration from 0 to infinity 1 by pi integration from 0 to infinity b omega sine omega x d omega. So this was what we were doing earlier. But in this case, because we are interested to calculate the Fourier cosine integral representation, so we won't take this term. And you'll see in a moment why we are not taking this term. Because here, what is the formula for a omega? It was f of t into cos omega t dt. F of t is now an even function. Cos omega t is also an even function. So their multiplication would also be even. So if this is even, so that means our integration from minus infinity to infinity, that now converts to 2 times integration from 0 to infinity. So 2 times integration from 0 to infinity of f of t cos omega t dt. And what is b omega? B omega was the function g of t into f sine of omega t dt. So now g of t, because this is an even function, sine is an odd function, so their multiplication would be an odd function. And we know the integration of odd function from minus same limit to same limit, that is 0. So that is why this term is not present in this integral form. So this is the expression for this integral form of cosine integral representation of any function f of x on the given interval 0 to infinity. Next, for the Fourier sine integral representation, we will again use the odd extension in place of even extension for the whole real line. So our interval, our function f of x is defined in this interval 0 to infinity. But now we extend our function to another interval minus infinity to infinity, such that in 0 to infinity its behavior is same, but we extend it from minus infinity to 0 such that it now behaves as an odd function, which is an odd extension of the given function. So for the interval x greater than 0, it is same f of x, and whenever x is less than 0, it is minus f of minus x. So that means it now behaves as an odd function. And how we have created this odd function? By taking its reflection about origin. So once we have created this odd function, so now what is a omega? A omega, the formula was integration from minus infinity to infinity g of x cos omega t dt. Now because this is an odd function and this is an even function, so the product would be an odd function. So odd function integration from minus same limit to same limit, that is 0. So this term won't be present in our representation. So we only have this b omega term. And what is b omega? That would be twice of integration from 0 to infinity. Why? Because gt was an odd function, sine t was also an odd function, so their multiplication would be an even function. And what is the value of gt in this interval 0 to infinity? It is equivalent to f of t only. So that is why we obtain the value of bw as this one. So when you substitute this value in the integral representation of your function f of x in this interval, so a series now becomes this. So this is about the series. How do we obtain such kind of? Next is the theorem for convergence. Now we will check how this series will converge. So for this series to converge, we have this following properties. First of all, the function should be piecewise continuous on each interval. Then it should be absolutely convergent on the real axis. And the third condition is that it should have left and right derivatives. So that means the Fourier cosine and sine integral representations, they converges to this point f of x at the point of continuity, and moreover at the point of discontinuity it is equivalent to this particular value. That means the left limit of the function evaluated at that point, that is this one, the right limit of the function evaluated at that point, and we'll take the average of these two. So this is the theorem.